Hello everyone! In the very previous videos What Mobile Networks, we discussed history of wireless industry, what networks can be named as mobile networks, and how they were evolving throughout generations. We discussed improvements in radio subnetwork part, bottleneck affecting overall throughput, then what nodes are inside mobile network with their responsibilities, a part of equipment with radio transmission, and finally some most important technological advancements, paradigm shifts, which improved overall mobile network quality of services and convenience of internal integration. If you haven't watched mentioned videos, it's better to do that before moving forward with this one. Let's think how useful such information could be for you on top of just curiosity. First and foremost, obvious need is for those who work or plan to work in mobile networks industry, especially with focus on technical engineering. It would be logically good to understand principles of how mobile networks work, what nodes and functionality they may consist of, and how to utilize evolutionary improvements happened up to date. This industry worldwide has millions of jobs on operators' side, which provides services to the end customers, and on vendors' side, which provides equipment and software to mobile operators. It might not be a huge percent of overall workforce across the globe, but industry is not super small and could change over the time. It's not growing nowadays, but some expansion could be potentially seen in future in some aspects. First aspect is, wireless infrastructure itself could be changed. And second aspect, some convergence, simultaneous technologies could be used naturally utilizing mobile networks. Let's briefly discuss few examples about it. Let's start with first aspect. Couple of serious improvements which we discussed in the What Mobile Networks videos, unification of IP-based transport and voice over IP brought new improvement, which we haven't discussed yet, voice over Wi-Fi. From its name you can guess that mobile network customer can receive voice service when mobile phone is connected to Wi-Fi router over the air instead of connecting to mobile operator's base station. By the way, each mobile network's base station has large coverage, several miles from its antenna to mobile phone. 1G network's base station had approximately 40 miles, 2G network's base station had approximately 20 miles. Wi-Fi hotspots on the other side have a very limited geographical coverage, up to approximately 30 feet or 10 meters from the Wi-Fi router. For mobile operator, it's easier to install thousands of regular base stations rather than millions of Wi-Fi hotspots to start providing mobile network service on a large countrywide geographical coverage area. That's probably why Wi-Fi was not a technology in mobile networks evolution roadmap for a long time. But specifications allowed to utilize two types of Wi-Fi routers, which belong to mobile operator, trusted routers, and third-party, untrusted Wi-Fi routers, using certain secure encrypting technologies. That means your mobile phone potentially can use your personal Wi-Fi router at home, or any other Wi-Fi router, for voice over Wi-Fi service. What is also important, specifications follow mobile network principles to provide seamless service regardless of which signal mobile phone is exposed currently, under Wi-Fi router or regular mobile network base station during the voice call. And that means 30 feet coverage no longer blocks implementation of voice over Wi-Fi. Nowadays, Wi-Fi routers are widely represented in city centers and work in most homes. Voice over Wi-Fi to me is an example of transformation of mobile network industry. Millions third-party mobile hotspots were utilized by mobile network industry. If you plan to work in this domain, you may need to dive deeper to understand how such change was reflected internally, which nodes were introduced within network. Let me just give you a brief idea to start diving yourself. We didn't talk in the previous videos about voice over IP in general. Let me bring particular example of voice over LTE implementation from 4G network nodes perspective. In short, mobile network is used as a pipe between mobile phones and special external packet data subnetwork designed for handling voice calls using IP protocol. Such subnetwork is called IMS core network. Even though such subnetwork is external, is not part of RAN or CN subsystems, main parts of mobile network. But logically, it should belong to the same mobile operator, not to third-party company, because IMS core network and packet data core network of the operator need to interact with each other during voice calls. By the way, IMS stands for IP Multimedia Subsystem, and voice is just one out of several services which this subsystem can potentially provide. Examples of other services are video calls, real-time messaging, etc. Here you can see subsystems. Here are 4G LTE nodes, which we discussed in the previous videos, our pipes for voice over IP, and all traffic will go through these nodes discussed earlier: E node B, S gateway P gateway, or S gateway U, P gateway U. Inside IMS core network, there are a few important nodes, but mobile phone talks directly with frontline PCSCF node, which is IMS core network gatekeeper. PCSCF is the first node facing mobile phones and allows to control, establish and end voice over IP calls. FYI, PCSCF stands for Proxy Session Control Function. We don't plan to discuss IMS core network further in this video. What important for us is absolutely the same IMS core network, which can be reached by mobile phones via 3G, 4G or 5G mobile networks, might be also utilized when phone is configured for voice over Wi-Fi service and subscriber is under Wi-Fi router coverage. Nodes chain and our pipe between phone and IMS core network will look differently though. Instead of E node B S gateway P gateway for 4G network, there should be Wi-Fi router EPDG P gateway. A Wi-Fi router is for over-the-air radio channels connectivity. A Vault Packet Data Gateway EPDG node is mainly focused on identification, authentication and security, which is checking subscription for voice over Wi-Fi service and providing secure tunnels between phones and EPDG. IMS core network resides upon exit from P gateway or P gateway U for both nodes chains examples. So UE and IMS core network can talk absolutely the same language, meaning use similar procedures for handling voice over IP calls, as long as either pipe for sending IP packets is in place. That was about wireless infrastructure expanding using lots of short distance Wi-Fi routers by mobile network customers for voice services. You never know how industry might be expanded with wireless infrastructure later. Let's a little bit talk about futuristic from the first look Li-Fi technology. Before to continue, let me share my experience of visiting Planetarium Cinema in Seattle's Pacific Science Center back in 2018. I was so impressed about story of matter distributed in our Milky Way galaxy. One of the idea was that matter in universe is largely represented by stars, and due to rotating it was squeezed to almost two-dimensional kind of disk with more matter closer to the layer going through disk's center. Our solar system with Earth is also within this disk. So Milky Way could be seen as a projection slice on our night sky. That's why Milky Way stars' light on a sky could be seen from Earth concentrated within a narrow band of stars. But most of us never ask a question to ourselves, why there is no brightest light in the center of such band, which should correlate with theory of the most stars' mass in the center of Milky Way galaxy disk. That's how it simplified looks on our sky. The question from that video followed up was with an answer. Scientists use devices which are able to detect signals reaching Earth from Milky Way outside of visible light range. And it turned out that infrared light, not visible by our eyes, completed the whole picture. And when scientists overlaid few pictures, including picture with visible light and picture from infrared light, preliminary converted to spectrum visible for humans, everything was on a proper place. That means lots of stars have huge masses but don't emit visible light, and black holes are even out of our discussion. And evidence gave a proof that the most matter is actually closer to the centered layer of Milky Way galaxy's disk. It's just about our eyes not able to see non-visible light on the night sky. Why I mentioned this story? In the previous video, What Mobile Networks, we discussed about electromagnetic spectrum within topic evolution of radio resources. We mentioned that for mobile networks in 5G, they started considering very high frequencies signals. Remember, LTE standard uses frequencies around 2-3 GHz? 5G radio planned to use also millimeter waves with frequencies above 24 GHz. But overall electromagnetic radio waves spectrum is way wider, potentially endless. If we draw wide spectrum on a picture and look into higher frequencies, then we could even see that there is some bandwidth which belongs to visible light, visible to human. Some of listeners of this video may be confused, but yes, light is a form of electromagnetic waves of a certain frequency range. Our human eyes can be considered as devices capable to detect electromagnetic radio waves of certain very high frequencies, frequencies corresponding to visible light. With Milky Way story a minute ago, lots of stars in center of galaxy radiate radio waves in different spectrum. It's not seen by our eyes, but can be detected by special equipment recognizing other frequencies ranges. In other words, human eyes' vision is extended using technology to see something outside of visible light spectrum. Radio waves used in mobile networks have frequencies way lower than visible light, even 5G's millimeter waves. But what's important now, regardless of frequency, any electromagnetic radio wave can potentially transmit some data to provide wireless service as long as signal can be more or less reliably delivered from transmitter to receiver. Visible light is not an exception. Now imagine, similarly to lots of Wi-Fi hotspots available for mobile networks voice services, we already may have prepared infrastructure for sending signal using light. There are a lot of light bulbs working throughout dark time on a city streets, in covered parking, we use light in our homes and so on. Of course, there are some specific features and restrictions which belong to light. For example, light cannot go through non-transparent materials if compared with mobile networks' invisible radio signals traveling through the building walls. Therefore, for using light, we need to have enough light hotspots, keeping in mind that signal could be easily blocked. And security questions to encrypt signals from user devices need to be carefully considered. Other than that, we just need to premix useful signal with electromagnetic waves of light to deliver packet data service. Here you can see where Wi-Fi technology, which is communication using visible light, could be potentially used. This is the second example of potential infrastructure expanding which could be utilized by mobile networks industry. Wi-Fi and Li-Fi are current and potentially future examples of the first aspect, wireless infrastructure expanding. Regarding second aspect, simultaneous technologies to be used utilizing mobile networks. One of the examples is virtual reality and augmented reality. These services for high-quality video require very high data throughput and very low latency. Otherwise, transmitted video would have non-realistic bad quality, and we cannot name services as reality, virtual or augmented. Of course, wired technology could deliver guaranteed signal transmitting parameters. But if we want to have mentioned services saying bye to wires, then required characteristics and something that 5G network slicing tuned for ultra-low latency and high throughput were designed for. Here we can see potential simultaneous use of mobile network industry with popular end-user services. That were few examples showing potential expansion to be seen in future in some first aspect, wireless infrastructure, Wi-Fi and Li-Fi, and second aspect, convergence, simultaneous use of mobile network technology utilized by other technologies like VR, AR. Going to the next topic. How knowledge of mobile networks could be also useful to you. In the previous topic we mentioned that it can be useful if you plan to work in mobile network industry. There is a separate subcase if you plan to own business in this industry. For example, if you want to start and run mobile network operator. It may sound strange because most people assume industry may look very well developed and too competitive. But let's look closely what could be done if you know how mobile networks are built inside and what features, possibilities might be helpful. The first option is to reuse existing radio infrastructure of currently working big operators. And it's widely used in the world by so-called mobile virtual network operators, MVNOs. like TracFone, Red Pocket Mobile, Mint, and others. And technically that becomes possible because of standardized multiple operators core networks (MOCN) feature. Just imagine that the same wide RAN coverage of main operator can be used by virtual operator, while such virtual operator may have just few centralized own core network nodes, full or partial core network upon agreement, and billing system. And no headaches with obtaining frequency spectrum license. How virtual operator subscribers could use base station of another main operator? The fact is, each operator has own unique mobile network identifier named PLMN ID, Public Land Mobile Network, which must be transmitted by base station over the air so all own subscribers can connect to that network to receive services. When virtual operator connects to the same base station of main operator, such base station starts transmitting both PLMN IDs. If subscriber of main operator comes to use network via this base station, all mobile phones messages from base station will be routed to core network of main operator, marked by its PLMN ID. Once subscriber of virtual operator to use services via the same base station, all messages will be routed to separate own virtual operator core network, marked with its different PLMN ID. It's like international arriving in the airport. All passengers arrived using the same aircraft and gate, but passport control will force them to use separate lines based on different IDs. Citizens go via main lane, while passengers with temporary visas go via another lane. How difficult it is to jump into this virtual operator territory? If you watched our previous videos What Mobile Networks, you remember that over generations there were some improvements, and one of them is virtualization of mobile networks. Mobile network nodes nowadays are not as strictly hardware and software proprietary as they were 10 years back. They can be now just software to be enabled over the standard hardware off the shelf with virtual infrastructure. You might be surprised, but even free open source software for core network nodes is available, like free5gc.org, open source project for 5GCN. And something similar could be found for 4G, which also started moving towards functions virtualization. Once you have software for minimum allowed number of mobile network nodes, even here you have couple of options. First, you can maintain your own hardware in some data center or couple data centers for redundancy. Or second, you can find out pay-as-you-go services from cloud service companies, which focused on taking care of maintaining their own data centers and give processors, storage, networking power to customers for rent. Amazon with its AWS virtual environment, Microsoft with its Azure networks, Google Cloud and others could take headache away from you and provide reliable, nearly 100% available, possibly redundant infrastructure for you. Of course, at some cost. But entrance to the market is very easy now. If commercial goal to provide services to any customers is out of scope, there might be other use cases which can save some money. For example, if you have international company with global presence and lots of employees, maybe you want to organize virtual operator specifically for your own 100,000 employees. I assume it should be very easy to integrate mobile network nowadays and give it to the IT department for maintenance. Such virtual network could be used for voice calls as well as for packet data services, including secure access to internal company's resources, email, documentation, etc. Second option regarding your own business. Probably you can even go with building your own mobile network from scratch, including base stations as well. It might not be a good solution in some countries, but I've heard in Mexico they are building mobile networks for connecting local communities, maybe sometimes free of charge or nearly free of charge for mobile network services. Probably this can be considered as add-on value for living in such communities. Here's the trick with this option. It may look like radio frequency spectrum is wide, but in reality it's heavily used limited resource. And it's better to grab more such resource than your competitors have. Remember from previous videos, the wider the bandwidth, the better throughput and consequently quality of services provided to subscribers. Lots of bandwidth are licensed by each country's government authorities. For example, Federal Communications Commission takes care of non-federal radio spectrum used in the USA. And mobile operators are paying a lot for spectrum portions. So how to jump into this territory? There are good news. Some spectrum bandwidth considered as non-licensed and can be potentially used without any payments for its use. What else to consider apart available frequencies? Core network nodes could be just software in 4G and 5G network. It should be doable for 3G IP-based network as well, or maybe already done. I mean to write just software for core network nodes. But base stations require some over-the-air communication, which certainly requires specific equipment to generate, transmit, and also receive signals. So where to find base stations for your project? There are some ways to consider. If you are okay to use a little bit outdated mobile generation network radios, likely it's possible to find lots of decommissioned but still working base stations from large operators which moved to modern generation networks and no longer plan to use old ones. That should not cost much, but you receive few problems here. You need to ensure that mobile phones still will be supporting radio standards. Another thing, likely base stations are radiating in licensed frequency spectrum. So without receiving license from authorities, it might be illegal to use them. And finally, most likely you won't receive any support from base station vendors in case of any hardware or software issues. There are all-style physical hardware and software solutions available on the market, as well as software-defined radios, SDRs, which is a product of virtualization, when you have radio transmitting hardware off the shelf and processing signal is happening on a separate computer this hardware unit connected to. For SDRs, there are well-known players like HackRF, BladeRF, USRP, and others. You need to realize that most of them are for short-distance solutions. Therefore, always check expected maximum distance, range from antenna to mobile phones. Mentioned solutions from SDRs may have signal strength enough to cover few feet up to 100 or something. For real mobile network, you may need more power to come to antenna and reach mobile phones at a distance of few miles. For that, you may need to find baseband units, BBUs, likely but not necessarily old-style physical hardware plus software, and connect them to remote radio frequency units, RRUs, usually right next to antenna. These are two parts of typical wireless base station made for modular design. Always remember to check a need for licensing for your planned over-the-air work before operating. If you want to save some money and have possibility, then choose unlicensed spectrum. For this spectrum, always remember that radio communication happens between two sides, base station and mobile phones, so be sure phones support the same radio frequency spectrum. Modern world is changing at a high pace. You may be surprised to find solutions from new players in the wireless domain, like NVIDIA, which deliver radio solutions based on their own processors, GPUs, to other well-known established players, like Ericsson, which could deliver base stations further to customer under its brand. So you may need to search in this area to find optimal solution which would work for you. And maybe there is a chance to find players which are not advertising radio solution to the end customers and probably could provide you equipment at certain discount. That were few thoughts about starting new business in wireless mobile network domain. Next thing why it might be interesting for you to learn more about mobile networks. Mobile networks are a very good example of complex distributed system with lots of nodes and procedures with lots of messages between nodes. That's starting from very first procedure of switching on mobile phone and lots of others till phone is powered off. You may not be lucky to land on a job on operator side, or there might be temporarily no openings, but still want to have hands-on experience and learn how distributed systems work on a mobile network example. Building a small mobile network at home is a perfect way to make it happen. Why it is so perfect? First of all, you will have non-trivial network integration experience when you will be configuring network nodes to connect them into one mobile network. Second thing, there are very good, comprehensive, detailed specifications written for mobile network. including end-to-end call flows and detailed content for each message within this call flow. And most of them could be found in one very good structured aggregated place, 3gpp.org. My personal recommendation: for learning, always refer to the latest version of each spec. Third thing, there are available network traffic protocol analyzers even at no cost to you, like Wireshark. They allow to capture, collect IP-based traffic between network nodes to decode and provide to you in a simple readable format. Usually such protocol analyzers have regular prompt updates, which means even recent updates in the latest spec releases will be somehow decoded pretty soon. Having theoretical papers, quick way to generate required procedures, and actual observed behavior, messages within triggered procedures, you can have a very nice available hands-on experience with mobile networks, good reverse engineering, and better understanding of design intent. You may likely guess why certain procedures appeared in the specs and were implemented. Such knowledge could be used in different technical aspects using analogical reasoning. If talking about design intent in focus, mobile networks are a very good example of understanding why certain procedures and their parts appeared in specific sequence. Why mobile networks are good for that? Because when they started being implemented, there were always limited resources available for lots of subscribers, while services to be reliably and securely always provided to end customers. Therefore, focus of all procedures was on decreasing amount of signaling traffic and keeping all necessary functionality in place. Even if you would look to any specific procedure, you could see elegance and admire a need of each step and meaning of any particular parameter included. For example, when the very first procedure happening, switching on mobile phone, there will be requests sent from UE to mobile core network asking for initial registration of a subscriber. We need to identify subscriber, but such information is sensitive, so in most of the cases nickname will be used instead of a real identifier. So in case any spy would listen signal over the air, he could not guess which subscriber is reaching mobile network. Next thing would be authentication of subscriber, kind of password checking. It is happening on the very next step for resources economy. There is no need to spend time on any other steps of procedure to figure out on later step that subscriber cannot provide proper password-alike information. On the very next step, ciphering of certain protocol will be switched on between phone and network to increase security even more and hide all further messages by encryption. There is no need to delay encryption enabling for later steps because it may bring vulnerability, and so on. All these procedures are very good examples of optimized logical way of requesting and handling resources. Couple of things to mention in regards for making own mobile network operational. First one, computers and software are not enough to have a full mobile network, even for pure virtual software-based 5G networks. You need nodes for last mile communication with mobile phones over the air, base stations. For that, for your home experiments, you may use SDR, software-defined radios, like HackRF, BladeRF, or USRP. They have radio unit working on certain frequencies, likely in licensed spectrum. Therefore, when working with it, put mobile phone and radio from this SDR in so-called shield box or metal cage, so radio signal not to escape outside and not to disturb other mobile users. Another interesting option: if you have some mobile phone prototypes, unlikely but potentially possible, some mobile phones have connector to use wired signal to be directly delivered instead of sending it over the air. It is physically possible and moreover allows to deliver stable signal to the phone without thinking of any antenna or connection issues on the way. In this case, you may skip sending signal over the air and take care of the radio frequency licensing problem, if any. Second thing for making own mobile network. For enabling mobile phone, you need SIM card. Such SIM card should have certain important information to properly reach and communicate with mobile network, starting from identifier of subscriber, some authentication, password-alike information, mobile operator network identifier, and so on. For learning purposes, I have couple of recommendations how to obtain such SIM cards. First one is to have special so-called SIM burner, which can be obtained from SIM card vendor like Gemalto. They allow to work on certain types or versions of SIM cards. Either you can try to reburn, overwrite information on existing compatible SIM card, or you can request blank batch of SIM cards for your home mini lab. In this case, you will have full control in recording, burning necessary information on a SIM card. Another variant is to reuse existing real SIM card from any operator. In this case, you have no access to original authentication data to be configured on the network side. But 3GPP specs potentially allow to disable authentication steps, which hopefully could be supported by certain mobile core network nodes, like SGSN or MME or AMF, in terms of configuring authentication switching off. If authentication is disabled, it doesn't matter what password-alike authentication information is burned on SIM card, it won't be used. The rest steps of procedures, except authentication related, should be still presented, which is still good for learning. That was about building a small mobile network at home to learn in details one of the examples of complex distributed systems, mobile networks. And the last topic. If you understood overall system from the high-level architecture point of view, in our case mobile network, you can better understand how each part of this system works, including mobile phone. That means mobile phone's network-related settings will be able to tell you much more than just set of strange parameters you blindly use. For example, what is APN in 4G or DNN in 5G? Why to use this one or that one? How to enable Wi-Fi calling? Or if Li-Fi appears, how to enable that one? There might be more benefits why it might be interesting for you to learn deeper about mobile networks. But let me finish this video with a brief summary what we have discussed so far. What benefits could knowledge of mobile networks give you? First and most obvious is if you plan to work or already started working in mobile network industry, especially in case of interest in technical engineering roles. We discussed that industry may be transformed to keep some roles opened over the time. First aspect was expanding of mobile network infrastructure, which moved from native 1G, 2G, 3G, 4G, 5G networks to addition of Wi-Fi and potentially other technologies like Li-Fi could be absorbed. Second aspect of convergence of several technologies where mobile networks may play a vital role as an enabler. Examples which we brought were virtual and augmented reality. Next subtopic discussion of your potential interest in case you plan to start your own business in mobile network industry. It's very specific flavor of working in the industry, and technical aspects overview should give you ideas and use cases which could be applicable for your interests. It might be mobile virtual network operator reusing radio part of existing operator. We discussed briefly details what else needs to be done on the top of reusing someone else's radio equipment, and possibilities to use third-party virtual network infrastructure like Amazon AWS or Microsoft Azure, and just software on the top of that. Alternatively, you can go with full mobile network implementation, including radio part, base stations. We pointed out to licensed, still major part, and non-licensed radio frequency spectrum to keep in mind. Another subtopic why it might be useful for you to learn mobile networks was about focus on learning complex distributed systems. Combinations of factors such as your own hands-on mobile network integration experience, perfectly written specifications, mainly 3GPP, available tools for collecting traffic make your endeavors in learning relatively easier, fast and fruitful. We pointed out two helpful items which you need to consider when implementing your home mobile network. Most of nodes could be just piece of software, even free of charge, running on virtual machines. You still need last mile equipment though. Remember software-defined radios which we mentioned? And how to obtain SIM cards suitable for your home mobile network? Additionally, we just briefly mentioned that mobile network-related parameters, settings on the mobile phone would make more sense to you if you know mobile network in a brief. Hope discussed topics could bring spark in your eyes and certain interest to dive deeper and learn more about mobile networks. MotivationHow portal has lots of other videos to answer your questions what and why regarding different techniques as well as technological and scientific aspects. Please check others and hope you will have fun watching them. See you!